Hello students, myself Dr. Vimal Rar, and today I bring you the first learning episode in BSc Forensic Science on an important unit which is overview of forensic chemistry, that is Forensic Chemistry Part 1. In this unit, we will discuss about the principles and techniques of chemistry which are involved in resolving crimes, and also you will be made acquainted with the knowledge on states of matter which shall form the basis for understanding the later episodes. We will wind up this episode with an interesting case study. Let us start our episode with a look at what we are going to learn today. The first module will deal with the introduction. The second module will take you to chemistry. The module 3 will deal with the crime and global society. Module 4 will discuss the scope and significance in forensic chemistry. Module 5 will deal with the classification of matter. Module 6 will take you to the study of periodic table, and in module 7 we will discuss the cases which are encountered in the forensic chemistry, and module 8 will be the conclusion. Forensic science in its comprehensive way is the use of techniques and principles of science for the resolution of administration of criminal justice system. You know that chemistry is a vital domain of forensic science, and forensic scientists must consider the principles, concepts and techniques of chemistry to perform their duties in an effective manner. Scientists of all types are often engaged in the arrangement of substance. However, the kind of substance may vary according to their nature of work. For example, pharmaceutical scientists identify the substances inside a drug sample to establish their expiry dates. Similarly, forensic scientists identify substance to connect suspects to the crimes or to reconstruct a crime, that is, determine how a misconduct has been committed. The very first history of forensic chemistry began with the analysis of poisons. In ancient times, there are evidences of the use of poisons by early Egyptians, Greeks and Romans, and at that time poisons were used both for murder and for the execution of death penalty. The philosopher Socrates was punished to death by consuming hemlock, and prior to the progress of any systematic scientific procedure of criminal investigation, circumstantial and hearsay evidence were usually employed to ascertain the guilt of any person. Arsenic was a commonly used poison during Roman times. The first occurrence of a real chemical examination for poison is the Blandy trial conducted during 1752. This area of science is usually reflected very fascinating, and it continues to experience increasing popularity. The current trend of individual attention in forensics is a direct result of various popular investigating programs on television. Many of the tests demonstrated in these programs involve chemistry, as you must have seen, like they use a substance to detect the presence of blood stains which otherwise could have been unnoticed, and that substance turns those spots into luminous stains, and that magical looking substance is actually luminol, which reacts with blood to form a compound that glows when illuminated under UV radiation in a dark room. In addition, the stories often show crime scene specialists bringing samples back to the laboratory for examination in any one of the several large machines that seem to print out a report in just a few seconds. But in reality, it is much more complicated than that. Chemists can analyze a substance in various ways in direction to determine its composition. After defining the configuration of the substance, they can compare it to already analyzed samples, and if they find a match between the sample obtained from the law breaking area or the crime scene and the known sample, then which is often called as control sample, By this process, they can identify the source of the test sample collected from the crime scene. Not only these television shows, but the media too has contributed a lot in the growth of forensic science. The coverage of different criminal cases has brought the scene of crime examination and forensic analysis out of the labs amongst the public. In order to understand the forensic chemistry, let us begin by studying or revising some of the fundamentals of chemistry. Chemistry, dear students, is the branch of science which deals with the study of the structure, composition, properties and behavior of matter. The word chemistry is derived from the word alchemy, which means study of matter by analysis, synthesis and transmutation. Chemistry is the only science which not only explains the behavior of different types of matter already existing in and around us, but it also creates new matter. The main concerns of chemistry are structure and behavior of atoms or elements, their composition and properties of compounds, reaction between substances and their accompanying energy changes, various laws that unite these phenomena into comprehensive systems. Chemistry plays a very vital role in our lives, to the extent that it will be almost impossible to live even for a day without making use of various benefits of chemistry. If we see closely, dear students, there is hardly any human activity that does not involve chemistry of chemical compounds, and there are millions of compounds already known to us and equal numbers are being added with the modern research going on all over the world. If we review our daily routine, right from the moment we get up in the morning and until we go to the bed in the night, we find ourselves associated with various things which are chemical in nature and have their origin in chemistry. Chemists try to explain the behavior of matter existing in nature, isolate the various chemical compounds, find out their structures, relate the properties associated with them for the use of mankind. They also try to synthesize them and many new chemical compounds in large quantities in an economical manner, so that they can be used for variety of purposes like as drugs, polymers, cosmetics, fertilizers, insecticides, pesticides, building materials, fabrics, rubber, paints, paper, dyes, soaps, detergents, vitamins, jewelry, etc. and the list is endless. Anything existing in this world comes under the scope of chemistry. It is the most important branch of science which helps in understanding the other branches of science as well. When we use the knowledge of chemistry to solve the forensic cases, then it is called as forensic chemistry. Forensic chemistry is a specialized subfield of forensic science involving the use of techniques and principles of chemistry to the field of forensic investigation. It involves complex procedures of chemical examination that are used to identify elements and compounds. Recognition events are extremely dependable and are often grounded on the physical and chemical properties of the substance, supported by the data obtained from various analytical analysis. Forensic chemistry is the use of principles of chemistry to law implementation and legal system. There are various analytical methods which may be applied to find out the chemical variations that occurred during any incident, and in this way it helps in the reconstruction of the crime scene, which is very important for you as the aspiring forensic scientist. Forensic chemistry meets the need of both the scientific and the legal communities by innovations in its research, practice and presentation. Each surface of the legal structure would suffer without forensic chemistry. So, forensic chemistry acts as armed force in the pursuit of justice and is a very important branch in forensic science. Forensic chemistry gives voice to the silent witness of physical evidence. It has a vital part in the administration of justice. It not only aids in the examination and trial of crimes, but it also supports in meeting up the ends of justice. The capability of forensic professionals to establish the presence of a link between the accused and the crime by corresponding physical evidence collected from the area of crime and those which are obtained from the victim or accused. We can say this is the law of comparison. It strengthens the case of prosecution. Forensic chemists perform different examination to isolate materials in way to determine the nature and composition of the given evidence. A vastly skilled forensic chemist is able to decide or give the decisive opinion on the composition and type of resources and can predict the foundation as well as corresponding evidences collected from the area of crime with a control sample. Modern chemistry applies the traditional analytical techniques hand in hand with much younger methods of analysis. Physical evidence collected from the areas of crime needs to be properly collected, packaged and sealed in special containers in order to preserve its reliability and to prevent contamination. A chain of custody should be maintained for each evidence which is sent to forensic laboratory for examination. After this, in the research laboratory or the forensic laboratory, the evidence is scrutinized by the trained personnel to reach up to a definite opinion. Forensic chemists have a vital part in forensic science laboratories, and when required, they are often called before the courts to provide testimony as expert witnesses. In these cases, the chemist may compare questioned evidence to the control samples and might be asked to give an expert opinion in court on the basis of grounds on which such opinion is based. Their speculative qualifications, besides the years of experience to deal with such analysis, render their opinion valuable and believable. The fact that most samples are submitted for analysis are contaminated with dirt or debris and several other contaminants. This poses a major challenge before a forensic chemist. So, every substance that is collected from the area of crime or the scene of crime has a unique composition that can ultimately be identified. Arsonists, for example, often use accelerants such as kerosene or gasoline to accelerate the rate of combustion, and each accelerant have its particular unique composition, which as forensic scientists you must know. A forensic chemist can search for and collect the burnt and unburnt material samples, remove the volatile hydrocarbons from them, and may use gas chromatography to separate the various components of these samples. After evidence is collected from the crime scene, all these evidences are then sent to the forensic lab for analysis. The forensic chemist follows a specific process as per the given scientific method for analyzing that very particular evidence. Samples poised from a crime scene and brought to the laboratory for analysis are called as questioned samples because the identities and origins of these samples are unknown. For reaching any conclusions about the identity or origin of these questioned samples, the forensic chemist need to know the samples as references, which are known as control samples. A control sample might be collected as a part of the evidence, for instance, a hair sample collected from a suspect. Forensic analysis may be achieved to first identify a quotient sample, or second, to compare a sample under quotient with a known sample for the determination of finding the source of its origin, that is from where it has come from. The consequences of such comparisons can link a quotient sample and several other known samples either to a class of samples with several possible origins, we can say classification, or to a single source which is referred to as individualization. So, thus dear student, a forensic chemist has to analyze much more than the quotient sample. A forensic analysis follows the order, identification, classification and individualization. The challenges found during each phase of analysis are actually different for different evidence. Often identification is straightforward and obvious to the untrained eye. For instance, hair, soil and various similar looking drugs. But the fact is that expertise and sophisticated instrumentation are needed for production of a proper and accurate analysis. The principles of chemistry play quite a vital role in each division of forensic science laboratory, and a few of them are examination of metallic amalgams and metal fragments for identification and comparison. The next one is analysis of traces of fuel products in forensic exhibits, comparison of petroleum products, adulteration of petroleum products and so on. The next one is examination of petroleum products like diesel, petrol and kerosene. The still next one is analysis of dyes, paints, inks, fillers, binders and several other chemicals to ascertain their identity, composition, excellence and quantity. Examination of low standard construction material like cement, brick etc. and the adulteration in these materials, analysis of various narcotics, designer and abuse drugs like bhang, opium, ganja, LSD etc. as well as illicit liquors also we will be studying in detail. Determination of liquor in blood and urine in cases of suspected drunkenness and analysis of fermented wash, varnish etc. in prohibition and excise cases. The next one is the analysis of pesticides for their identification, examination of ignitable material in suspected action of arson, dowry deaths etc. Analysis of explosives, firearms and ammunition. Let us start this particular module of chemistry by investigating some fundamental conducts in which matter is categorized and defined. Two principal means of categorizing matter are as per their physical states, that is as a solid, liquid or gas, and conferring to its arrangement, that is whether it is an element or a compound or a mixture. Now, let us discuss about this in detail, that is the states of matter. An example of matter can be a solid, a liquid or a gas, and these three forms of matter are known as the states of matter. The states of matter vary in some extent noticeable properties. For example, a gas which is also known as vapor has no stable volume or form, rather it adapts to the size and form of the vessel. A gas can be compacted or compressed to live in a smaller size, or it can be inflated to inhabit a larger size container. On the other hand, a liquid has a distinct size self determining of its vessel, but it has no particular form or shape. It takes the shape of the portion of the vessel where it is there or it lives in. A solid in contrast has both a definite shape and a definite volume. It is unbending. Neither the liquids nor the solids can be compacted to any noticeable degree. In a gas, the constituent particles are far away and they are moving at great rapidity, crashing frequently with each other and even to the barriers or the wall of the vessel. In case of a liquid, the particles are filled more thoroughly together, but still they can move quickly, permitting them to slip over each other. So, therefore, liquids transfer effortlessly over each other. In the case of a solid, the particles are bounded compactly with each other, and generally in terms of arrangement, they have a particular arrangement where the particles can slightly wiggle only to some extent in their then static position. So, thus we can say solids have stiff shapes. Pure substances. Maximum type of matter that we come across for illustration: the air we respire, that is a gas, petrol for cars, which is a liquid, and the footway on which we stride, that is a solid, are actually not chemically pure. We can though resolve or separate these kinds of matter into different pure substances. So, what is a pure substance? A pure substance is usually denoted to merely as a substance, is actually a substance that has particular properties and a composition that will not change from sample to sample. Elements cannot be disintegrated into simpler substances. So, they are pure substances. Similarly, compounds are material comprising of two or more elements. So, they are comprised of two or more type of atoms. Water, for instance, is a compound comprising of two elements, hydrogen and oxygen. So, mixtures are arrangement of two or more constituents where every constituent preserves its specific chemical identity. Talking about elements, the observation that the basic arrangement of an unadulterated compound is every time is similar is called as the law of constant composition, or also the law of definite proportion. It was first put forth by the French chemist Joseph Louis Proust in about 1800. Though this law has been called for 200 years, the common trust exists between some persons that an essential alteration exists among compounds arranged in the laboratory and the analogous compounds found in nature. However, a pure compound has the similar arrangement and properties regardless of its source. Both chemists and nature must use the same elements and operate under the same natural laws. Most of the matter we encounter consists of mixtures of different substances. Each substance in a mixture retains its own chemical identity and hence its own properties, whereas pure substances have fixed composition. The compositions of mixtures can vary. Some mixtures, if we take examples, are like sand, rocks, wood, and they do not have the same composition, properties and appearance throughout the sample, you can say, and such mixtures can be either heterogeneous or homogeneous. Heterogeneous mixtures, they are having non-uniform composition, and homogeneous mixtures have a uniform composition. For example, if we talk about air, air is a homogeneous mixture of the gaseous substances like nitrogen, oxygen and smaller amounts of other substances. The nitrogen in air has all the properties that pure nitrogen does, because both the pure substance and the mixture contain the same nitrogen molecules. Salt, sugar and many other materials, they mix in water to form homogeneous combination. Homogeneous combination or homogeneous mixtures are also called as solutions. Chemical properties of every element are known by the element's electronic arrangement and particularly by its outermost valence electrons. An element's position in the periodic table is mainly based on its electrons, the number of valence shell electrons, they determine its group, and the kind of orbital where the valence electrons lie, that determines the element's block. In addition, the entire number of electron shells an atom determines which period it belongs to. And because of its structure, the periodic table has developed an enormously valuable instrument for measuring and calculating elemental and chemical trends. The periodic table inclines all the elements with info about their atomic weights, chemical symbols and atomic numbers. The agreement of the periodic table leads us to visualize certain trends among the atoms. The vertical columns, which are called as groups in the periodic table, they are arranged such that all its elements have the same number of valence electron. All elements within a certain group thus share the similar properties. On the other hand, periods are the horizontal rows in the periodic table, which signify the total number of electronic shells which are there in the element's atom. Atomic number is equal to the number of protons in an atom that determines its chemical properties, and the symbol used is Z. Group is a vertical column in the periodic table which indicates the number of valence shell electrons in a component's atom. Forensic chemistry comprises the chemical examination of a number of physical evidence. These include samples of assumed accelerants from noxious chemicals, arson debris, propellants, lubricants, gunshot residues, etc. The cases that are typically examined by using the help of forensic chemistry, they include homicides, arsons, assaults, robberies, etc. And a few of them are discussed here. Let us first take arson investigation. Arsonists may apply a number of accelerants to set a fire, and during the analysis of any arson scene and its background cause, investigators must look for the fire debris that they believe to contain the residues of the accelerants used in arson. The remains need to be collected and filled in airtight vessels to prevent the loss of its volatile substance, and it is then transported to the forensic science laboratory for examination. Mass chromatography or gas chromatography, they are employed to identify and quantitatively analyze the traces of ignitable liquid residue which are collected in the samples. Along with this, the forensic chemist often concentrate on several other minute residue traces. They do this by using activated charcoal bands to absorb the accelerant residues, which are then separated from the band by dissolving it in a suitable solvent. Let us talk about gunshot residue. Apart from arson remains, this division analyzes evidence linked with bombardment circumstances. When ammunition is discharged from a weapon, gases are produced which contain charred and unburned constituents of primer and propellant cartridge, which may deposit on the hands and clothes of the individual gunfire the weapon, and this is referred to as gunshot residue, that is GSR. Scanning electron microscope coupled with an energy dispersive spectrometer is used to examine tape lifts taken from the hands of the suspected shooters. If elements like barium, antimony and lead is found in these samples, it is classified as primer residue. Let us move to another case, which is of toxins. Forensic chemists examine an enormous array of evidence like blood stains, urine, etc. for the drops of drugs or poisons inside them. Many businesses, including sports, now require the drug screening of employees and the sports persons. It is the chief task of the forensic chemist to distinguish between the external addition of illegal drugs and metabolites from certain food materials like poppy seeds. So, such tests may be as simple as a various color test, or they may involve different instrumental methods oscillating from simple to complex one. Paper or thin layer chromatography or complicated techniques like gas chromatographic or electrophoresis could be used for the analysis of different toxins. In death cases, due to unknown cause, samples of the victim's blood, lungs, urine, stomach content and vitreous humor are examined for drops of poisons, etc. Insects in some cases found on the dead bodies are also examined, as they may have absorbed some of these drugs or poison from the foam in the trace amounts, which sometimes are found long after, even when their concentration in the foam have reduced substantially. Noxious chemicals. Noxious chemicals like capsaicin spray and tear gas can be both qualitatively and quantitatively analyzed by using the gas chromatograph mass spectrometer, that is GCMS. Tear gas is a constituent in the dye packets that are used by banks to identify the suspects, as they can be present on the wear of the person involved after the dye pack has exploded. Then there are various miscellaneous analysis which a forensic chemist can do. The forensic chemistry can also help in investigation of sexual assault cases by examining the lubricants, even when they are present in trace amounts used by suspect in rape cases. So, there are various analytical methods which may be applied to find out the chemical variations that occur during any incident, and in this way it helps in reconstruction of the crime scene. A well skilled forensic expert is able to determine the arrangement and type of substance and predicting the origin and comparison of evidences which are collected from the scene of crime with the control sample. Modern chemistry employs the traditional analytical techniques hand in hand with much younger methods of analysis. So, dear students, I hope you have enjoyed the contents of this lecture, and I would really appreciate if you guys try to practice what you have learned after each episode. If you want more information regarding this topic, you can visit our website, which is www.cec.nic.in. So, dear students, keep studying and goodbye for now.